Say when you're doing grocery shopping and you have $20 to spend, you see the following pairs of items on the shelf. You make a decision of purchasing one of these pairs based on your preference. In consumer theory, when consumers make a decision, they make a decision based on their preference relation. Preference relation describes consumers' taste in terms of ordering one set of items over another. In economics, preference relation is often expressed by a utility function. For example, if the utility function is u equals AB, and if you pick 2 apples and 3 bananas, your utility is 6. In other words, your feelings towards purchasing 2 apples and 3 bananas are expressed as 6. It's easy to compare two sets of items using our utility function and compare their utilities. In this video, we'll explain and prove the theory stating that there exists a real valued function that is representing the preference relation. If there are two arbitrary sets of items, as long as the utility of one is higher than the utility of another, then the consumer will prefer one over another. Let's look into utility function in more detail to understand the theorem better. An utility function is simply a function that maps m-dimensional input to one-dimensional output, which is utility. If we think in 2 dimensions, it can be visualized like this. Most of the time, it is more convenient to work with utility functions to explain concepts in consumer theory, as you can employ calculus and other mathematics. This video will go through some key concepts to explain the theorem, such as consumption set, 4 axioms defining preference relation, completeness, transitivity, continuity, and monotonicity. Then we use these key concepts to prove the theorem. First of all, the consumption set portrays all of the choices a consumer can conceive, regardless of constraints such as budget or capacity. It solely captures all possible consumption plans in terms of what they can think of. We let a consumption set X and let X be a vector containing different quantities of each of the n commodities and call X a consumption bundle. All of the consumption bundles on the yellow curve have the same utility. Consumers compare these consumption bundles and make a choice based on their preference relation. Preference relation gives structure to the consumption set. We'll look into 4 axioms building up the preference relation and how it gives structure to the consumption set X. Completeness. Consumer have the ability to compare and order any bundles. You can pick any 2 bundles, X1, X2, X3, and X4, and consumer can decide which one they prefer more. Transitivity. Consumer choice is consistent. If the consumer prefers X1 over X2 and X2 over X3, then the consumer prefers X1 over X3. If the binary relation satisfies completeness and transitivity, the binary relation is called consumer preference on consumption set X, and every element in the consumption set X can be ordered. There are 2 more axioms you can add to introduce the notion of strict preference and indifference preference. Continuity. Small change in a consumption bundle does not change the preference drastically. For example, consumer prefers buying 5 apples more than buying 4 apples just by a little. Monotonicity. More quantity means higher preference. 5 apples is always greater than 4 apples. When you compare the consumption bundle X1 and X2, it is easy to tell that consumer would prefer X2. However, you can say the same thing for X1 and X3. Even though X1 and X3 seems to be in the same bundle, X1 slightly has more quantity and thus consumer prefers X1 over X3. To prove the theorem, we just have to show that there exists at least one function that satisfies the preference relation. Let's define a condition that if you choose an arbitrary bundle X, there is a function outputting a number ux, which makes uxe indifferent to the bundle X. There is a consumption bundle X on the blue curve, and any points on the blue curve is indifferent to the consumption bundle X in terms of preference. You define a reference vector E, which is 45 degrees from the bottom axis. Then this vector E is scaled by Ux to reach the blue curve. The consumption bundle UXE is indifferent to consumption bundle X. To use the condition to express preference relation, there are two questions to answer. Does there always exist a number Ux satisfying the condition? Is U a well-defined function, which means there is only one unique output Ux for every X? We'll use completeness, continuity, strict monotonicity to explain that there exists a number Ux. We define two subsets A and B in consumption set X. Graphical representation of both A and B are shown in the left diagram. Green region is expressing the subset A, and red region is expressing the subset B. The condition is satisfied if the region A and B overlaps, meaning the intersection of subset A and B is non-empty. From the axiom of continuity and strict monotonicity, subset A is closed and T in subset A will increase as the quantity increases. Thus, the subset A is closed interval from T lower to infinite. In the same way, you can also conclude that the subset B is the closed interval from 0 to T upper. From the axiom of completeness, T is the element of the union of subset A and subset B. We define that T lower is lower than T upper, and this means that the intersection of subset A and B is non-empty. This demonstrates that there exists such function Ux that makes UXE indifferent to the consumption bundle X. To show that the function U is a well-defined function, we'll use the axiom of transitivity. Ux can be expressed as T1 and T2. Using transitivity, T1e and T2e are indifferent to X. Then T1e and T2e are also indifferent, and thus T1 equals to T2. Ux is a well-defined function. After showing the function is well-defined, and there always exists such function, you can combine it with transitivity and strictly monotonicity to prove the theorem. The equality are showing how the real valued function U is representing the consumer relation. One last thing to show is that utility function U representing preference relation is continuous. To prove a function is continuous, we show that the inverse image of every open set U is open in R and positive. It is equivalent to show that U inverse of an open set A to B for every A and B is open. To express what's shown in the diagram algebraically, here's what it looks like. Consumption bundle X is an inverse image of U, given that Ux is between an open interval A and B. Using strict monotonicity and the condition, the right-hand side of the equality can be transformed into something like this. Then we'll rewrite the right-hand side of the equality like this, which is the intersection of open sets AE and BE. Thus, we can conclude that the function U is continuous. This is the end of the proof. The function U has all the property of completeness, transitivity, continuity, and strict monotonicity that allows the function U to represent preference relation. Here's a quick recap of this video. We first looked into what the theorem means. Then we went through 4 axioms that preference relation is built up on. To actually prove the theorem, the condition Ux indifferent to X is defined, and we saw that Ux is a well-defined function which always exists. Later, we checked how Ux is satisfying 4 axioms, namely completeness, transitivity, continuity, and strict monotonicity. These are the steps to prove that there exists a real valued function representing preference relation. Thank you.